Hello, let's review your MT8 LT1 seminar on the multiplication property of exponents. First thing I want you to do is answer the first 5 questions. We'll review those in class, or answer the first 5 questions and move on to activate your prior knowledge about exponents. What we're going to do is we're going to find the product of monomials. We'll talk about a monomials in a couple minutes. We're going to find the power of a power and the power of a product. Those are the 3 things I want you to learn. First of all, let's look in our textbook at Launch the Lesson. And what happens here is we're going to look at most computers have a binary system. It's composed, all our code is essentially zeros and ones. So we're going to write those as anything with a power of 2. So when I look at, here's our matrix type of thing with their computers, everything is to a power of 2. We're going to learn how to simplify those power of 2 and find and evaluate those answers in different ways. Now, first off, a monomial. Mono means 1. So it's to a single number or a combination of numbers and letters. I gave you a bunch of examples of things that are monomials here. So it's a product, which means multiplying, not adding. So we're going to just be multiplying. Any kind of number, it could be positive, it could be negative, it could be a fraction, and our exponents with variables. Now, our variables are really simple. They keep it simple. There are no negatives. There are exponents. There's no fractional exponents. Nothing weird with your variables. So let's take a look at things that are not monomials so we understand that when we come across here. And maybe we'll put another example of things that are monomials. Okay. So for example, we said you can't be adding. So x plus y is not a monomial. Okay? You can't have any negative exponents. You can have negative numbers, but if we have 4x to the negative 2, that's not a monomial. Nor can we have like 5x to the 3/4. Now you can have a fraction. Like let's say I have negative 5/6 x to the 6. That's a monomial because I can have any number I want. But the variables have to be simple. They have to be nice positive whole numbers. Now when we have multiplying, when we have a power, this whole thing is called the power. The exponent is the 2. And the base is the 8. So I'd say 8 squared or 8 to the 2nd. 8 to the 2nd means 8 times 8. We've kind of done that. 2 to the 4th. 2 times 2 times 2 times 2 is 16. If I have like 3 to the 2nd times 3, well, 3 to the 2nd means 3 times 3. 3 to the 3rd, I take 3 to the 3rd. Now I can write those with an exponent, can't I? 3 times 3 is 3 to the 2nd. 3 times 3 to the 3rd, 3 times 3 times 3. Notice I got 5 3s, no matter how I do that. Notice, though, I can add those, can't I? So what happens, as long as I have the same base, that's the key. So if I have like x to the a power times x to the b power, exponents are different. They're weird. When you multiply exponents, we add them. So this is x to the a plus b power. Notice when I add, I don't add, do I? 2 to the x is plus 2 to the x is not 4 to the x squared. It's 4 to the x. But when we multiply, we add the exponents. So if I take a look at example 1 here, I can rewrite this. Let's use the commutative property. 3 n to the 4th times 4 n to the 7th. That's actually 3 times 4. My rules for exponents don't change how I multiply. times n to the 4th times n to the 7th. 3 times 4 is 12. We multiply our numbers. We add our exponents. It's n, 12 n to the 11th would give us our answer here. We can do the same thing over here on letter B. And on letter B, I've got 3 things, so I'm just going to reorganize this. I put my numbers together, 7 times 2. I'll put my x's together, x times x to the 4th. I'll put my y's together, y squared times y cubed, because my rule doesn't work unless the exponents or the bases are the same. 7 times 2 is 14. How many x's do you have here? Well, if we take a look here, I've got 1x here and 4x is there. What's 1 plus 4? Well, that'll give me x to the 5th power. I've got y to the 2nd, y to the 3rd, so I get y to the 5th power. We multiply, we add the exponents. Multiply the numbers, but add the exponents. Now we can take that, well, we'll do that in the next seminar, in the next video.